Using the sum of GP, prove that a raised to the power n plus b raised to the power n, where a, b, n all are natural numbers, is divisible by a plus b for odd natural numbers, only for odd natural numbers. And hence prove that 1 raised to the power 99 plus 2 raised to the power 99 and so on up to plus 100 raised to the power 99 is divisible by 10100. Here we want to prove that a raised to the power n plus b raised to the power n is divisible by a plus b. In order to prove that a raised to the power n plus b raised to the power n is divisible by a plus b, we need to prove that the result of this expression should be an integer. We can manipulate this expression by taking a raised to the power n common from the numerator. So we'll have 1 plus b raised to the power n over a raised to the power n divided by, and from the denominator, if I take a common, it will be 1 plus b over a, right? And which can also be written as a raised to the power n minus 1 by dividing a raised to the power n with a by using exponent formulas. And here, if we write 1 minus b over a raised to the power n, it will not affect the final result because we are talking about odd natural numbers. So if n is equal to, let's say, 1, then it will give you the result as 1 plus b over a, right? Because this will be negative b over a. This is negative, correct? Okay. And the denominator, again, it can also be written as 1 minus b over a. And that is same as a raised to the power n minus 1 times 1 multiplied by 1 minus negative b over a raised to the power n over 1 minus negative b over a. Now this is in the form of a times 1 minus r raised to the power n over 1 minus r, correct? Here a is 1 and r is equal to negative b over a, correct? And now you get the reason why we wrote negative and negative b over a, because we wanted to use the formula for sum of GP. So now we have sum of GP formula, and we can go in the reverse order. From the sum of GP formula, we can write the series. So a raised to the power n minus 1 times, the first term is 1, and the common ratio is negative b over a. So the second term will be a times r, so plus a times r. The next term will be a times r raised to the power 2. The next term will be a times r raised to the power 3, and so on, right? So this is a raised to the power n minus 1, 1 minus b over a plus b square over a square minus b cube over a cube, and so on. Which can also be written as a raised to the power n minus 1 if you multiply a raised to the power n minus 1 inside. So you have a raised to the power n minus 1 minus b times a raised to the power n minus 2, because a raised to the power n minus 1 divided by a will give you a raised to the power n minus 2. Similarly, the next term will be b square times a raised to the power n minus 3, and so on. As we know that a, b, and n all are natural numbers, so this expression here will give you an integer answer always. As this represents an integer and there will be no remainder left, therefore we can say that a raised to the power n plus b raised to the power n is divisible by a plus b. Now moving on to the second part of proving 1 raised to the power 99 plus 2 raised to the power 99, so on up to 100 raised to the power 99 is divisible by 10100. Here we can use the fact that a raised to the power n plus b raised to the power n is divisible by a plus b if n is odd. In order to prove that this expression is divisible by 10100, which is basically 100 1 times 100, we can prove that this expression is divisible by 101 and 100. So let's do it. We can regroup the terms as 1 raised to the power 99 plus 100 raised to the power 99 plus 2 raised to the power 99 plus 99 raised to the power 99 and so on, right? So here each group is in the form of a raised to the power n plus b raised to the power n. So it will be divisible by a plus b, right? Here a plus b gives you 101. So that means this total expression will be divisible by 101. And in the similar manner, we can regroup the terms as 1 raised to the power 99 plus 99 raised to the power 99 plus 2 raised to the power 99 and 98 raised to the power 99 and so on. But there will be two terms left out, which are 50 raised to the power 99 and 100 raised to the power 99. So the first group is divisible by 100, second group is divisible by 100, and all the groups will be divisible by 100. 100 raised to the power 99 is also divisible by 100, and 50 raised to the power 99 is also divisible by 100. So here all the groups are divisible by 100. Now we have proved that 1 raised to the power 99, 2 raised to the power 99, and so on up to 100 raised to the power 99. This series is divisible by 100 as well as 101. So therefore it is divisible by 10100.